Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing your answers about sound waves. Paper 4, we have homework for extended candidates. Question number 2, we have a dolphin produces sound waves in water. The frequency is 7,800 Hertz, representing rarefactions of sound waves traveling in water hitting the side of a wooden ship at an angle. First part is asking you to define rarefaction. What do you mean by rarefaction? Rarefaction means a region of low pressure where particles or molecules are further apart. Okay, can you tell me in the comments what do you mean by compression? Okay, on the figure we have two rarefactions A and B are labeled, and the distance between rarefaction A and rarefaction B is 0.76 meters. Back to the diagram here between A and B. Okay, these perpendicular lines showing rarefactions, they are wave fronts. And you know that the spaces or the distance between wave fronts representing wavelengths. So how many wavelengths we have here? We have 1, 2, 3, and 4. Okay, so this part is asking you to calculate the wavelengths of this sound waves in water. So you have to divide this distance, which is 0.76 meter. So the wavelength is equal to 0.76 meters. All this distance from A to B. Okay, you have to divide this by 4 because we have here 4 wavelengths. The answer is 0.19 meters. Is it clear? Okay, the second part is challenging because we have here many steps, 2 steps. The time taken for the rarefaction you have to determine the time taken for the rarefaction at A to reach rarefaction B. You have to use wave equation to find speed first, and then you can use your result to find time. So since you have the wavelength, which is 0.19, you have the frequency, which is given at the beginning of the question here. So you have to substitute and find the speed, which is 1.482 meter per second. Okay, time is equal to distance traveled divided by speed. The answer is the distance from A to B is 0.76 meters. Check units are consistent, and the speed is 1482 meter per second. Your answer is 0.00051 seconds. Okay, so you have to write it as standard notation or scientific notation as a standard form. So you have to write it as 5.1 times 10 to the power negative 4 seconds. Okay, as scientific notation. Is it clear? This is very important. Okay, the next part of the question, the sound wave passes from water into wood, where the speed of sound is greater. And even if this is not mentioned, you know already that water is liquid, wood is solid, so you know that the speed of sound in solids is more than speed of sound in liquid. What happens to the frequency and what happens to the wave length? What happens to the frequency? Now we are talking about refraction. Sound travels from a medium to another medium. So back to our wave equation, we have here the frequency is constant. What are the changes here? Changes, we have speed is changing and we have wavelength is changing. So what happens here? Refraction. During refraction, the frequency will be kept constant. The speed increases. The speed increases. So what happens to the wavelength? The wavelength accordingly increases. They are directly proportional when the frequency is constant. So the frequency is unchanged. It will be the same value as mentioned in the question, which is 7800 hertz, as mentioned in the question. The wavelength increases according to the speed. Sketch, the next one is very important also. Sketch positions in the wood. You have to draw wave fronts, rarefactions. Back to the question. Okay, I will use the ruler to draw. Okay, remember when we were drawing from shallow water to deep water, from deep to shallow, what happens? Here the speed is increasing. So here in this medium, in wood, what happens? Speed increases, wavelength increases. Okay, so the direction of wave travel will not be the same. It will be, or it will bend away from the normal, since it enters now, the wave will enter a region where the speed becomes greater. So what happens to the direction of wave travel? It will bend, it will change its direction, it will be away from the normal. Okay, I will draw one normal and we will repeat for the other wave fronts. I will draw it in red. So here, if we continue the direction, I will draw it here. Okay, so this is the direction of wave travel. Make sure that all wave fronts are perpendicular to direction of wave travel. When you draw normal to the boundary, what happens? The direction of wave travel will change, it will bend, it will be away from the normal in this direction. So this one will be the new direction of wave travel. So I will draw the other. So all these red lines, the direction of wave travel. Okay, so all these lines in red, the direction of wave travel. I will draw now the wave fronts. Wave fronts should be at, okay, let's draw it in yellow. I will draw the wave fronts should be at right angle to the direction of wave travel. So I will draw, and they should meet the rarefactions or wavefronts which already drawn in the figure. So here we will draw them at right angle parallel to each other, and you can see at right angle to the direction of wave travel. And if you look at the wavelength, you will see that the wavelength becomes longer. It's more than before.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.